We hear all the time about the big tech giants and their amazing AI models. But there's this huge debate happening kind of behind the scenes that could have massive consequences for national security. And it all boils down to one really important question.
Basically, should the code, the secret sauce that makes these things tick, should it be locked away by a handful of companies? Or should it be open for anyone, and I mean anyone, to look at, play with, and even change? We're going to dive right into that because, and you might find this surprising, the Pentagon has a huge stake in how this plays out.
So, right at the heart of this whole thing is what's called an open foundation model. Now, this isn't like the AI you might mess with on a website. With these open models, the core components, what the experts call the weights, they're just out there. They're public. That means you, me, anyone can download it, tinker with it, and yeah, run it on your own computer. Okay, so let's really break it down. The main difference is pretty simple, right? You've got your open models on one side, their guts are public, you can tweak them and you can run them locally. Then on the other side, you've got the closed models, think GPT-4. That stuff is proprietary. You can only talk to it through an API, and it all runs on some company's giant server farm. And believe me, this distinction is everything in this debate. All right, so here's what we're going to cover. We'll start with this whole open versus closed debate and figure out why it's suddenly a big deal for national security. Then we'll get into the nitty-gritty, the specific perks open source gives the Pentagon. We'll see a wild example of it controlling satellites, and we'll unpack why running AI on premises is an absolute must-have for the military. And to wrap it all up, we'll look at the bigger picture, what this means for the future of AI itself. Okay, let's kick things off with the main argument. It's a real tug of war. On one side, people are saying, hey, we need to regulate this stuff for safety. And on the other, you've got folks shouting, no, we need to keep it open to drive innovation. And look, both sides have a point. The critics, they're worried that some bad actor could grab an open model and weaponize it, for cyber attacks, maybe even something scarier. But the supporters fire back that openness is actually our best defense. It means thousands of smart people can poke and prod at it, find the flaws, and fix them. Plus, it stops a few big companies from cornering the market. So, what's the right way to think about this? Is AI like nuclear material something that needs to be locked down tight? Or is it more like cryptography back in the day, something the government wanted to control but which ended up becoming the bedrock of the entire secure internet? And that's where national security comes roaring into the picture. See, the Department of Defense, or DoD, relies a lot on commercial tech. And as AI starts showing up in literally everything from drones to complex battle networks, the companies building these AI models, well, they're basically becoming a new, super critical part of the defense industry. And that's where things get risky. This CSIS brief we're looking at draws a really interesting parallel to something that happened back in 1993, called the Last Supper. Basically, the government pushed a bunch of defense companies to merge, and it created these huge consolidated giants. The worry now is that if we get too restrictive with AI policy, we could end up doing the exact same thing, forcing the Pentagon to rely on just a couple of massive companies with closed proprietary models. So you might be asking, why would the Pentagon actually want a more open AI world? Well, it all comes down to 4 key strategic advantages. And these are things that are just non-negotiable for military ops. Let's run through them. First, supplier diversity. An open market means the Pentagon doesn't get stuck with just a few giant contractors. Second, something called competitive sustainment, which is a fancy way of saying they aren't locked into one company for maintenance forever. Third, security. Pretty simple. They can actually look at the code themselves to check for vulnerabilities. And fourth, they can build really specialized AIs for unique military jobs that you'd never get from a commercial off-the-shelf product. Okay, let's go a little deeper on that competitive sustainment thing, because it's really important. Think about it like this. You wouldn't try to maintain a fighter jet without the technical blueprints, right? It'd be impossible. Well, it's the exact same idea with AI. You can't really maintain, update, or properly secure an AI system if you don't have its blueprints. And in this case, the blueprints are the model's weights. If you're locked out of those, you are completely at the mercy of one single company for the entire life of that system. That's a huge problem. Okay, enough with the policy talk. Let's see this stuff in the real world. We're going to look at an actual command system that's used for tracking satellites, and you'll see how an open source AI is doing something pretty incredible. So picture this. The challenge is just huge. You have operators trying to manage this crazy complex network of ground sensors to keep track of thousands of different things flying around in orbit. Normally, this means writing specialized, clunky code. It's a pain. But what if you could just talk to the system like you're talking to a person? Well, that's exactly what's happening here.
An operator can now just use plain, simple English to tell this incredibly complex network what to do. And this is a perfect example of where open source AI is just a game changer. It lets developers build a custom, super secure interface that completely transforms how the job gets done.
I mean, just look at this command. The operator is just talking. They're laying out all these super technical details in one normal sentence. They're naming the target, the sensor, the priority, how many pictures to take, how often to do it, and they didn't have to write a single line of code. That just blows the doors open for who can use the system. And what does the AI do? It takes that sentence and, in a flash, translates it into a perfectly formatted JSON command. That's the super precise, nerdy language the machine actually understands. It's the ultimate translator, bridging that gap between what a human wants and what a machine needs to do. Okay, so you're probably thinking, wait, why does this have to be an open source model? Can't a closed one do this? And the answer to that gets right to the absolute core of military security. For the DoD, data protection isn't just a feature, it's everything. Think about it. A closed model that runs in the cloud, that means you're sending sensitive, mission-critical data to some company's server. For the military, that's just a complete non-starter. No way. But with an open source model, you can run it on premises, on your own secure internal computers. That gives you total control over your data. And crucially, it lets you air-gap the whole system. That means you can literally unplug it from the public internet. For this kind of work, that's not a nice to have. It is an absolute requirement. All right, let's pull the camera back a bit. This whole debate we've been talking about, open versus closed, on-prem versus cloud, this is way more than just a techie argument. What we're really talking about is shaping the entire industrial foundation for what is arguably the most important technology of our generation. And here's the thing you have to understand. Open source models are getting good, and they're getting good fast. Yeah, the closed models are still a bit ahead on this specific satellite task, but an open model like Mistral, it's a real contender now. And get this, just 1 year ago, the success rate for open models on this exact same task was literally 0. The gap isn't just closing, it's slamming shut. And the stakes for getting this policy decision wrong, they are sky high. That CSIS brief throws out a pretty shocking statistic to hammer this home. After decades of policies that led to consolidation in the shipbuilding industry, the U.S. is now outproduced by China by a ratio of 230 to 1. Let that sink in. The warning couldn't be clearer. We cannot afford to make that same kind of mistake with our AI industrial base. So in the end, this isn't really just about who has the best code. It's a competition of values. Choosing to build an AI ecosystem that thrives on competition and transparency, that's a strategic choice. And for the US, encouraging a really healthy, vibrant open source community seems to be a huge part of that strategy. And so that brings us right back to where we started, to that big central question. If we want to build an AI future that's both safe and secure, especially when it comes to something as important as national security, what's the right move? Do we lock it down behind corporate walls? Or do we open it up and let everyone help build it, check it, and make it better together?